hmm
Hmm.
Yeah, and there's some experimental evidence for that.
Hmm. Hmm.
Uh, it's kind of interesting. Yeah.
Hmm.
But of
And
course, the downside is when you have lower oxygen, that stresses you in other ways.
yeah, 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 yeah. So yeah, it quickly gets complicated. But
Right.
do we know anything about how acute changes in oxygenation affect sleep wake cycles and things like that?
I'm sure somebody knows, but I don't know very
Yeah,
much
yeah.
about that.
Okay.
Yeah.
Um, I want to talk about as well. So we talked about this concept of internal desynchronization earlier. You have your central clock that's really paying attention and trained to the light environment. But then you can have other clocks in your body, like I'll just call metabolic clock in your liver, and it may or may not be synchronized with the central clock. So these things can be desynchronized. And you basically told us that when those things are desynchronized with each other in your body, that's not optimal from a health
Mhm.
standpoint. You basically want all of these internal clocks to be synchronized as much as possible. I'm guessing that's probably a general rule or principle here. Another type of rhythm I want to ask you about. This is again an area where I'm not sure how much you've done personally, but you can let me know. When we think about learning and memory, and we think about, obviously you have to be awake and paying attention to learn about new things, but at the same time, there's probably some amount of memory consolidation and things like that happening during the sleep phase. What do we know about rhythms in learning and learnability? Are there circadian rhythms in terms of, like, an animal being able to acquire and remember things more at certain times of day or parts of its rhythm?
Yeah. So where it's been looked at, you can show a clear diurnal difference in both memory formation and recall.
Mm-hmm.
So, for example, in mice, you can conduct context-bent fear conditioning different times of day.
Mm-hmm.
So, um, we did that like many decades ago, and you can actually see a quantitative difference with time of day. And so, um, other kinds of experiments that have been conducted are to look at long-term potentiation at different times of day. And again, you can see a quantitative difference. You can have more effective LTP at one time of day versus others. So I think what that's telling us is that, synaptic transmission is not just the same all day. It's likely being modulated in a circadian fashion.
Mm-hmm.
And obviously, for consolidation of memories, there's decades of work in how sleep is essential for consolidation of memories in many different ways.
Mm-hmm. Mm-hmm. When we think about, so in humans, there's a lot of variability in circadian like behaviors, or things. People tend to like to do things at different times, oftentimes. So people talk about being morning people or evening people, night owls, and you see that kind of variability where on average people tend to either be sort of more active or feel uh, of them optimal, more of their optimal self earlier in the day versus later in the day, even after the sun goes down. To what extent do we observe that kind of variability in experimental animals? And have we studied it at all? Do we know why individuals in a population might tend towards one or the other in terms of being more active on the earlier or later part of the cycle?
Yeah, if you look at wild-derived animals,
Mm-hmm.
there's tends to be a much broader range in, preferred activity time, the onset. So you can document that. But even in inbred laboratory mice, there can be significant variation depending on
Hmm.
the mouse strain. And so, those are presumably all close to genetically identical individuals, but there are many other epigenetic factors that are probably causing variability in their circadian systems. So I would say humans have an extremely broad range of preferred wake up time, say.
Yeah.
Um, and we now know that that's largely genetic. Uh, Many genes contribute to the propensity to be either a morning person or an evening person. And the majority of people are evening people.
Really?
Yeah, I would say only, I mean, in the laboratory, only 20% of individuals are what we would call genetically morning people.
Hmm.
The other 80% have circadian. So when I say that, what I mean by that is that if we measure the circadian period of a person in the laboratory under
Yeah.
controlled conditions, 20% of those individuals have a period length that's less than 24 hours. 80% have a period length longer than 24
Mhm,
hours.
mhm. That's the norm for it to be a little bit longer.
Yeah. And if your clock is longer than 24 hours, that pushes you towards being a later person.
Yeah.
Whereas if your clock is shorter, that pushes you toward being an earlier person.
Hmm. And do we have, is there any pattern to that? Or is it kind of like, can you predict ahead of time who in a population will be the earlier person versus the later people? Is there any rhyme or reason to it and anything that we can use to explain why we see that pattern?
Well, as I said, it's largely genetically
Yeah.
determined. So if you were to genotype the person, then you have a pretty good prediction on their tendency.